Hello, my name is Rick Gwynn, and I'm here because I want to tell you about an exciting topic within the world of video. Okay, you got me. Actually, I'm here just because I need to get a good grade in this class that I'm taking for college. Okay, so without further ado, let's get this presentation started. Every year, millions of people turn on their televisions only to find boring shows, reality reruns, and depressing news documentaries. If left unchecked, a condition known as video depression can occur. Yes, Brianna. It's video compression, not video depression. What is compression? Compression is defined as the reduction in size, quantity, or volume as if by squeezing or pressing together. Sorry about that. It's supposed to be about video compression, not... Let's take it from the top. One more time. Video compression, please.
What is video compression?
Video compression is a technique used to reduce the number of bits that are required to represent a video image. Although this presentation is about video compression, it is important to remember that compression exists for almost all of today's electronic communication devices. So why do we need video compression? Digital cell phones use compression to allow more users on limited bandwidth, while digital cameras use compression to fit more pictures onto the camera's memory card. And MP3 players use compression to fit huge files of music from compact discs to miniature memory chips inside of most of today's portable audio players. Compression's main function is to reduce the size of the incoming data stream without removing the important information. This will increase the bandwidth and means that less will be required in the transferring of the data files, which can then be loaded directly onto memory cards and most of the chips in today's electronic devices. So how does compression work exactly? Using the KISS approach, where we'll keep it simple and you know the rest of that. Data files or videos are loaded onto a computer and fed into a compression engine. From there, the compressed data or file stream is then sent over the internet. The file stream is decompressed at the receiving client's terminal, and finally the file is retrieved and viewed by the user at the final destination point. There are two types of video compression: lossy compression and lossless compression, and we'll discuss both of those now. Lossless compression means that when a video is decompressed, it will be in a perfect match with the original. Lossless compression does not remove any data from the source whatsoever. An example where this would be used would be a binary sequence program or a new computer software program. The removal of even one bit alters the program dramatically. Lossy compression removes much of the data that is not actually necessary for achieving good picture quality. In most audio and video files, a portion of bits can be removed without sacrificing the image or sound quality of a file. Lossy compression is what is typically used for most video compression applications. An example of this would be the MP3 files you download onto an iPod. It has often been said that the hand is quicker than the eye, and in video compression it is no different. Perceptual coding and compression enhance compression further by exploiting the fact that humans don't necessarily notice slight changes in color, as opposed to brightness. This technique also allows loud auditory sounds to mask quieter sounds, which also can be removed. There are several benefits to compression. First, compression files use less space on memory cards and hard drives. Next, compression streams can be transmitted using lower bit rate networks, In other words, people with slower speeds can also enhance this. More compressed streams can also fit into the bandwidth stream, and finally, compressed signals can be sent faster than real-time signals. There are, however, several disadvantages of compression. Due to the removal of unnecessary bits, the picture or sound quality is usually less than the original quality. Compression sometimes causes delays in the signal. It also becomes much more difficult to edit video material when certain bit information has been removed. Video compression requires many complex calculations known as algorithms on the incoming signal, which increases the chance of error. And finally, the compression and decompression engines must both match perfectly for the compression to take place. If you're like most people, you've seen the letters MPEG, JPEG, and AAC across your computer. What does it mean? Well, MPEG stands for the Moving Pictures Experts Group. This is the group responsible for some of the most advanced compression systems used today. The group is generally given credit for developing the standards for video as well as audio compression. JPEG stands for Joint Photographic Experts Group. This format is the recognized standard for compressing of digital still photographs. JPEG also uses the lossy perceptual compression technique. Finally, the development of AAC, or Advanced Audio Coding, allows users to use an advanced audio compression system while they're using the MPEG-2 or MPEG-4 video streams. Okay, so how do the guys at MPEG work their magic? Well, the MPEG guys use different frames to reduce the input data video stream. First, iframes or intraframes compress data using only the data that is contained within its actual frame. This frame contains the most information of the three different frames found that make up the MPEG group. P-frames are frames that have been compressed using data that is contained inside of its own frame, as well as data from the closest preceding I or P frame. And finally, B-frames are frames that have been compressed using data from the closest preceding and the closest following I or P frame. These frames are all put together to make a train of frames, and we're going to cover that one in 1 second. As previously mentioned, we were talking about the framing order. If you'll notice right now, there's a string of letters up there. The frames in the MPG combination system begin with an I frame, usually followed by 2 B frames, and following up with another P or I frame. Remember, these frames can be set differently depending on your compression settings. Wow, that's a lot. That was a whole lot of information. I hope you got all that. Bree, did you understand it?
I did not get a word you said.
Okay, because actually I'm lost too. But what we can tell you in its simplest and most practical format is you can take, using compression, all of these albums and all of these videotapes and end up placing them on this little iPod. So if you get nothing else, compression is used because all of this and all of this can fit on something like this. What do you think?
That sounds okay to me.
Alrighty. Thanks for being with us. I first would like to say I'm sorry about this. I almost forgot this part of the presentation. I'd just like to say thanks to all the people that made this possible. Well, that would only be myself and, of course, my lovely, wonderful daughter, Brianna, who helped me with so much of the editing and stayed up long past many bedtime nights helping me with that. So, Brianna, Daddy loves you. Thanks a lot. Bye-bye.